Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's video, we will talk about one very important and very useful tool to handle complex circuit problems. That important tool is Kirchhoff's second law, and this law is also called KVL. In today's video, I will introduce KVL and also we will answer some complex circuit problems. Kirchhoff's second law is telling us that the voltage across a circuit component is equal to the sum of the voltage drop across the devices in that loop. So what exactly it means? It simply means that in any loop, So what is a loop actually? As if you remember from the previous video, I explained to you, loop is a closed path. So it's a closed. Okay, so this is an example of loop. So in any loop, delta V has to be equal to 0. So you can see from here, if I start from this point, let's say this point is A, if we go anti-clockwise and we come back to the same point. So we have one loop. So in this case, delta V has to be equal to 0. But there are a few points we need to understand. Some kind of conventions. We have to be very clear about that. For battery, we will follow a simple convention for a battery. So that convention is for a battery, and also on the other hand I will also write down for other components of circuit. I will simply say resistor. For example, if we have a battery, let's say like this, battery has two terminals. If we go from negative to positive terminal, we will gain voltage. We will say V is plus, and if we go in reverse direction, meaning if we go from positive to negative, we will say voltage is negative. For resistor, we need to understand if we will use this convention. If we go in direction of current, let's say our current is flowing this way. If we go in this direction, V should be negative because energy is used by component, and so V will be negative, means voltage is lost or voltage is dropped. On other hand, if we go in the opposite direction, let's say if I current is flowing this way and we go in this direction, so in this case we should be positive because we will gain voltage. Now in this case, if we apply this same principle here, if I start from this point, I go this way, I go from negative to positive, it means I will gain voltage. So I will say V in this has to be positive. But in this case, current is flowing this way. If I go in direction of current, I will lose voltage. So it has to be minus. Now in this case, again, we will lose voltage. It has to be minus. It has to be equal to 0. So what we can write from here now, I will just write down here. So in this case, you can simply say that V in is equal to V1 and this is equal to V2. So this law is basically based on law of conservation of energy. Means the total energy produced by this battery is equal to the total energy used by these components of circuit. Okay, so here you can see V in is equal to V1 plus V2. On this slide, you can see there is another example of Kirchhoff's second law. The circuit is given to you and I have already written for you this one. So just have a quick look at this one to have better understanding of Kirchhoff's second law. So you can see the first loop is A, B, C, F, G. So this is A, B, C. So we have this loop. So this is over loop 1. In this loop, if we apply Kirchhoff's second law, so you will find out that V is equal to V1 plus V2. So V1 is here and V2 is here. We can simply apply and we will get this one. And in the second loop is A, B, C, D, and then is E, F, G. So simply this loop. So the second loop is this one. So this is our second loop. In this loop, if we apply Kirchhoff's second law, we will find out that V1 is V1 plus V3 is equal to V. So this will be satisfied. And by comparing these two loops, we will find out that V2 is equal to V3, because you can see from here we have V, here we have V1. Only difference here is V2 and V3. So it means these two also has to be equal. So by comparing, we can find out this one. Now let's talk about the last loop actually. The last loop is this one, is this. So this is CFED. So this is the last loop. In this loop, if current is flowing this way, so the voltage will drop across here, but this is in the opposite direction of current flow, so we will gain voltage. So we can simply say that in this case V3 has to be positive and V2 has to be negative, and delta V has to be equal to 0. So we can simply say V3 has to be equal to V2. So this is how we can get. And again, this law is based on conservation of energy, means the total energy produced by the battery is equal to total energy lost by components. Voltage and energy, they are linked together because voltage is simply energy per charge. So the voltage is energy is conserved. The voltage lost and gain also has to be equal. The voltage is equal to energy over charge. So this is what we need to understand. Let's try to answer this question using Kirchhoff's second law. So in this question, what we need to find is, we need to find I. So what is value of I in this circuit? So it's a very straightforward one. We just follow the steps and we can answer. So in Kirchhoff's second law, we have studied that in any loop, delta V has to be equal to 0. So let's say we start from here and we go this way in clockwise direction. So we are going in clockwise direction. Sometimes it is also good if you draw small arrows. So it is very helpful. You can also draw these arrows. Now we are going clockwise. We started from this point. I can also say this is A. So it's good thing to label actually. So when I cross this one, so this is a positive terminal of the battery and this is a big battery. So of course the current flow will be due to this one, not due to this small battery. So we have a big battery here. So for this one, we can simply say if I cross this one, I will go from high voltage to low voltage. So we will simply say this is minus 5I. And for this battery, if you go from positive to negative, again you will lose voltage. So we will say this is minus 10. And again in direction of current, so we have minus 15I, and we go from negative to positive, we will gain, and this is equal to 50. And all, if we add up, it has to be equal to 0. So let's simplify this one. So we can write down this is 40, 50 minus 10, and if you add these two, we will get that is 20I, and this has to be equal to 0. So we can also write down like this, that 20I has to be equal to 40 and I has to be equal to 2 amps. So this is equal to 2 amps. So this is our final answer. It's a very straightforward. You can follow the same procedure, or you can follow the same steps for any circuit, any complicated circuit. So you will get the right answer. But you have to be consistent. So here I also actually wrote here for you. So our final answer is 2 amps as we found here. In today's video, we have covered basics of Kirchhoff's second law, or simply we can say KVL. In next video, we will do complex circuit problems and we will solve them using Kirchhoff's laws. Here is next time question for you to try. You can try this question first of all by yourself. And then you can compare your answers with my answers. If you couldn't get correct answers, no need to worry. At the beginning of next video on Kirchhoff's laws, circuit problems, I will explain this question in detail, and also we will do more complex circuit problems.